All right, chain rule. Chain rule, this is the method for computing derivatives of composition of two or more functions. So we've seen if I have two functions being multiplied, I can go through product rule. If they're being divided, I can go through quotient rule. But what if I had one function inside the other? So this is a composition function. So the way we find the derivative is we're going to follow this rule here. So here you can see that g of x is inside the f of x function. So the process is f prime of g of x times g prime. So what does that mean? I think verbally you can say it this way. It's the derivative of the outside function times the derivative of the inside function. So it does kind of have a little bit of a similarity with product rule because we are involving the multiplication of two expressions that are being ultimately from our derivative, but it's in a very special form here. It's going to be outside derivative and then inside derivative. And so we take the derivative of the outside function while keeping the inside portion unchanged, and then we multiply by the derivative of the inside function. So we want to show you, how to identify that inside and outside portion if you're looking at something that is in composition form. So for instance, f of x equals 3x squared plus 2 to the fifth. Now, this is raised to the fifth power, which if we want to do power rule, that will take a long time. Then we've got to FOIL everything out and then put it all back together and do power rule for each. The only time you have to really expand in this course is if it's degree 2, right? That's very manageable. We can do degree 2. Anything higher than degree 2, we want to explore other options besides expanding. So the idea is that rather than expanding all this out, why don't we think of this as an outside-inside component here? So here, the outside component of your expression is this parentheses to the fifth power. And then the inside portion is going to be that 3x squared plus 2. So an easy way to visualize this is whatever is outside the parentheses is your outside expression. Whatever is inside your parentheses is your inside expression. So imagine this parentheses as its own variable. Pretend like this is x to the fifth power, but instead it's parentheses to the fifth power. We can go through power rule here. What's the derivative of this if you treated that as a variable? Yeah, 5 parentheses to the fourth power. That is the outside function derivative. That is what f prime of g of x means for this problem. Now, when you take the outside derivative, you're not going to make any changes to the inside because we're just focusing on the outside. We're not touching the inside just yet. So you're just going to copy the inside as it is. So that's what this notation is saying. It says take the outside derivative, but leave the inside alone and recopy it. So that's what we're doing here. Times, now we're ready to move on to the inside portion. And we can find derivative there of that. So 3x squared plus 2, what's the derivative of that? 6x. So there's my g prime. Here's my inside portion. Outside derivative times inside derivative. A lot more efficient than trying to expand all this out and then power rule and then put it back together. The only cleanup that I would do is I like to, if I see an easy way to merge the coefficients together, then I'll do that. But technically we're at the derivative. Number 2, find all the values of x for which the function for where f prime is equal to 0 and where f prime does not exist. So f prime equal to 0, another way to think of this is this is a horizontal tangent. versus where f prime does not exist. So this is a vertical tangent. Just want to provide a visual for you in case. Check this real quick. Okay. All right, so we want to find the derivative. We know that anything dealing with horizontal and vertical tangents comes from f prime, so we got to get to f prime. But to get to f prime, let's first rewrite our function. So how can we rewrite the function so that we can more easily see what we're looking at? Parentheses x squared minus 1 to the what? Two over 3, yeah. So now we can clearly see that this is, we can't just do power rule, right? This is, we can't expand this, not in this form. We have to leave it in this form here, but we can clearly see, okay, there's an outside, inside component. We're going to go through chain rule here. So the outside component is just that parentheses to the 2/3. And the inside component is just that x squared minus 1. Yes.
Sorry, why can't we power rule?
We can't do power rule because remember one of the conditions for, or 3 conditions for power rule is, first is it has to be radical to rational, which is fine. Second is no variables in the denominator. That's fine. But all parentheses have to be resolved. So that's the issue. We can't resolve the parentheses, and we can't expand it. So we're kind of stuck. And because we're stuck, we can't just do power rule. We need something a little bit more involved, and that is chain rule here. So let's find f prime.
Thank you.
Okay. Yeah, good question. So outside's derivative becomes what? Two-thirds raised to the, we do power rule for this portion, right? Negative 1/3. Okay. Keep the inside intact. Times 2x, yeah. Let's do some cleanup so that I can clearly see my numerator and denominator, and I don't have to stare at a negative exponent. So I'm going to put all the numerators together. Let me highlight the numerators so you can see it. So the numerator is going to be the 2, and the x. If I put those together, I can make it 4x. And the rest will be my denominator, because once I get that parentheses to show a positive exponent, all that x squared minus 1 is going to go down to the bottom, and that's going to share the same space as that 3. So 3 x squared minus 1 to the 1/3. Question so far? So we want to find horizontal and vertical tangents. Horizontal tangent means slope 0. Vertical tangent means slope undefined. So here's the general rule here. If you're looking at the derivative and you want to find a horizontal tangent, you're going to set the numerator of f prime equal to 0 for horizontal tangent. And then you'll set the denominator of your f prime equal to 0 if you're looking for your vertical tangents. Let me just give you an idea of what the graph looks like. Oh, obviously, you're not gonna have to graph it, but I just want to show you, that the answer that we get is going to be consistent with what the graph shows. So the graph looks something like this. So if I were to ask you where the vertical tangents were off of this graph, where would you say they occurred? So vertical tangents means slope undefined. Where do you see slope undefined? So slope undefined means places where there's a sharp turn. So anytime you see a sharp turn, like a corner, there's no slope defined at a corner. So do you see corners? Yeah. So -1 and 1, right? These are places where slope is undefined. Do you see any slope zeros on this graph? When x is equal to what? Zero. Yeah, I'm sorry, I didn't do it perfectly there, but I meant for that peak there. If you have a smooth curve, then we can say that's a slope 0. So vertical tangent is at -1 and 1, and the horizontal tangent is at 0. We should be able to get that data from our algebraic steps here. So I'm going to set my numerator equal to 0, define my horizontal tangent. So I'll set 4x equal to 0. I'll solve for x, divide both sides by 4. I get x equals 0. So that's consistent, right? At x equals 0, I do see a horizontal tangent, and we're getting that data as well from the derivative. Okay. If I want to find my vertical tangent, I'm going to set my denominator equal to 0. And I should get a data that's consistent with what I see in the graph here. So algebraically, the way we solve this, divide both sides by 3. We square both sides to undo that square root.
1/3, isn't it?
Oh, sorry, 1/3. My bad. 1/3. Oh, sorry, yeah, you're right. I got to cube both sides. Thanks. And because I cube both sides, I'm just left with x squared minus 1. Solve for x. Now to undo the square, I'm going to take the square root. Plus or minus shows up. I get x equals plus or minus √1, which is the same thing as x equals plus or minus 1. So -1 and 1, the derivative gives us consistent information from what we see in the graph. So again, horizontal tangent is where there's a smooth curve and the slope is 0. Vertical tangent is like a sharp corner. Yeah. Yeah, you could. Yeah, you could. At that point, you could do x plus 1, x minus 1, and you'll get the same thing. Yeah. Good. Page 2. Find the equation of the tangent line of the y at x equals -3. So we know that ultimately tangent line is finding order pair and finding slope. Slope comes from the derivative. So let's go ahead and build the derivative. But we're going to practice using chain rule here. We're going to bring that x plus 2 up to the top. That way we can avoid quotient rule. Remember, you only are forced in the quotient rule if your numerator and denominator are both showing variables. In this case, my numerator is a constant, so I can avoid it if I just bring that x plus 2 up to the top.
Could use quotient rule though.
You could, but I want us to practice specifically with chain rule here. And if you did quotient rule, you have to still involve chain rule. It's just kind of like a nested problem. But this one feels a little bit cleaner, where we can clearly see that we can't do power rule because we can't resolve those exponents. So we're kind of involving chain rule here. So we got to identify outside, inside. What's the outside function here? 4 parentheses to the -2. Yep. So that's your outside component. And hopefully we can see, okay, I can just do power rule to get that derivative out of the way. And then what's my inside component? X plus 2. So we'll take turns with each derivative to build our y prime. Okay, outside first. Yeah, -8. Parentheses to the -3. Okay, what goes inside here? Yeah, we don't change yet. We don't make any changes to that. Okay. All right, so now we're done with the outside. Let's move to the inside. What's x plus 2's derivative? Just 1. Okay, so it's just times 1. All right. Let's do a little bit of cleanup. All right, you have everything that you need in front of you to build your tangent line equation. You have y prime to get your slope. Your y of x will give you your order pair. So find your order pair, find your slope, and then point slope form. Try that for a moment. I'll be right back. Thanks. So, oh,
What do you guys think?
Thank you. What do I get? What do I? That's like that dirty.
I know.
Oh, yeah.
Right, you can wait out once, 97.5.
What?
I'm not. Yeah. All of in my slide or.
I still don't get how the ones I missed are.
There's like 2 fluid jets of those.
I got one.
I don't want to speak on.
Yeah. We do weird ones.
your order pair will be -3, -3, 4. Then y prime of -3, that's going to be where you're going to get your slope information. Slope ends up being 8. 2 negatives become positive, and then point slope form.
Why couldn't you do power rule?
Power rule on this one, or which part?
Like the very first part where I put 4.
Oh, you mean doing power rule at this stage? Remember, we can't do power rule if variables in the denominator. Yeah. I mean, but you could do quotient rule. You could do quotient rule and do f prime g minus f g prime all over g squared. You can do that. But I want us to do this specifically practice with quotient rule, with chain rule. So I brought that up to the top so that we can avoid quotient rule. Questions? But yeah, we could do quotient rule for this, but typically, if either your numerator or denominator is a constant, I like to avoid quotient rule just because it's just a little messy to go through. I only want to do quotient rule if I'm forced into it usually. Example 4, y equals parentheses x minus 1 over x squared minus 4 to the third power. This looks like a complicated problem. We can't rely on just quotient rule. There's more to it than that. And this is going to be a quotient and chain rule. But let's identify our outside-inside portion, right? What's the outside component? Parentheses cube. And then my inside component is, yeah, the inside component is whatever is inside the parentheses, right? So the x minus 1 over x squared minus 4. So I can think of that as my f and my g, my outside and my inside. Oh, you have to call it f and g here. You can just say outside and inside. So we start with our outside component. What's the outside derivative?
3.
Yeah, 3 parentheses squared. And then once you get past that, then the inside is going to require what rule here? Quotient rule, yeah. So you're going to set up your f prime g minus fg prime. All over g squared. Let me work it out in separate sheets so you can see all my steps here. Okay, this is the only calculus step in the problem. The rest is just clean up, but any questions so far? Everyone see where I got all those pieces from? Now, as far as cleanup goes, really the main thing is trying to do cleanup with this. We just want to try to get that down to some sort of a where we can combine like terms if possible. So just off to the side here, I'm just going to have a way of cleaning that up there, and then I'll put it together. So x squared minus 4. And really, this is the same thing as distributing a negative 2x through the x minus 1. Remember, with multiplication, I can always rearrange terms. So this is the same thing as saying negative 2x parentheses x minus 1. And if I do it that way, I get minus 2x squared plus 2x.
But it's not minus 2x.
Because I put the 2x with the minus, and then I distribute that through, and I got a plus. And then that cleans up to be negative x squared plus 2x minus 4. So this is my updated version of that numerator if I were to do a little bit of cleanup. All right, so now let's just put it all under one fraction. So the 3 goes in the numerator, so I can put that there. Okay. How many x minus 1s do I have? 2. So x minus 1 squared. And then the rest in the numerator is just what I have there. right? How many x squared minus 4 do I have here?
2.
Good. Why is it 2?
It's square.
It's squared, right? I just want to point that out because I think a lot of students, they see, oh, the x minus 1 is definitely squared, but they don't, some students don't see that the x squared minus 4 is squared as well because it's a little further away, but it is still getting impacted. So there's 2 x squared minus 4 here. How many are there here?
2.
2 as well. What if I put it together? So this would be a reduced version of my derivative.
Why are we adding back in the inside parentheses if we use those for quotient rule?
So technically, this is a derivative. Technically, if we leave our answer in this form, we would, anything past this point is just cleanup. So I'm just trying to put things together, merge stuff together as best as I can. And I saw an opportunity where, okay, I have x squared minus 4 squared, I have x squared minus 4 squared. I'm just putting it together in a that feels like a little bit cleaner, but really these are the same things. We're not changing anything between these two. We're just trying to create an easier version. Okay, this one, number 5, is a little bit more involved, but it is also a combination of two rules here. How can I rewrite this so I can maybe see some exponents? Yeah, you can do times, but let's just put it over divided by what? Yeah. Okay, can you see two rules involved in this problem? What do you see? There's quotient, because I see numerator and denominator. Now, I could bring this up and make it product rule. That's also possible. But okay, either product or quotient. Let's just stick with quotient so we can just all do the same thing. What else do you see? Chain rule. Sorry, quotient.
Does it matter which one we do?
Well, we need to do both. But maybe your question, I think the question I was going to ask is, how do we know which one to do first?
Yeah.
Right. And so, this one is also quotient and chain, but the order is going to be different. Okay, so here's maybe a way to kind of put things together is look at the set of parentheses. You see how the parentheses is over the entire problem here? For this one, is the parentheses over the entire problem?
No.
No, it's only over a smaller portion. So I think the general rule of thumb is apply the rule that has a wider reach first. So in this case, chain rule has the wider reach because it's over the entire thing. So when I see parentheses over everything, I know chain rule is going to be coming first. And then whatever is inside is going to come next. Here, the parentheses is only over a portion of the problem. Quotient rule has a larger reach than the parentheses. So in this case, the quotient rule is going to be applied first. And then once we're inside quotient rule, then we can apply chain rule when we get to that G prime. Okay. So look at the parentheses. If parentheses is over everything, then chain rule is first. If parentheses is only over a portion of the problem, then it's the other rule that comes first. So in this case, quotient is going to come first, and then chain rule is going to follow. So let's set up quotient rule. All right, let's walk through this step by step here. What's f prime going to be? Okay, g function. The whole thing, right? Okay. Minus
X.
Okay. Now G prime, we got to do what? Function within the function here. So we got to go through what for G prime? Chain rule. Yeah. So within my G function, my outside component is the parentheses to the 1/2. And then my inside component is the x squared minus 1. Okay, so so it's like a problem within the problem just to get to that G prime there. Right? What's the outside component's derivative? 1/2 parentheses to the negative 1/2. What goes inside? X squared minus 1. Okay, so we're done with the outside components.
How is that doing chain? That's just doing our rule.
Yes, we are doing power rule for this component, but it's chain rule because we're splitting it up and doing outside inside separately. Yeah. Times, what's the inside derivative? 2x. Now we're done with G prime. That's what G prime looks like. All divided by what? What's G squared going to look like?
X squared minus 1, 3 over 2.
Not 3/2, but I see where you're trying to do here. We got to raise that to the second power, right? What's gonna happen here? 2 and 1/2. Multiply, yeah. They could if you see two exponents next to each other, you're gonna be multiplying them. Okay. So we have the derivative. Let me just do a little bit of cleanup here. So my cleanup here, x squared minus 1 to the 1/2. I'm gonna leave that alone. My main opportunity of cleanup is just within this region here. This can combine into something a little bit better, but the best we can do is put the cleaned up version of that in this space. We can't let it bleed into this denominator. It's being separated by, these terms are subtracted by one another. So we can't just push something down to the other side. So here, I'm going to put the numerators and denominators together. So the x, the 2, the x will all go in the numerator. So I get 2x squared. The 1/2, the x squared minus 1 to the negative 1/2, all that's going to go in the denominator. All over x squared minus 1. Now we could go a little further here, but I just want us to be able to at least get the negative exponents resolved and show that I can't push this x squared minus 1 to 1/2, negative 1/2 all the way down to this space. I can't let these two share the same space because I can't drag this out of the numerator here. This minus sign is forcing this to stay up here. We can't drag that down unless we want to find further common denominators. But we could do this, though. We cancel out the 2's, but we don't have to. Okay, page 3. Let's do a couple of chain rule problems, and then we'll do some more practice with your quiz review. Okay, look at number 1, page 3. You see a need for chain rule for number 1. Yeah. 2, anytime you see a parentheses with an exponent greater than 2, typically we don't want to try to expand. We want to rely on a more manageable rule. So we definitely want to take advantage of chain rule for number 1. Okay? So identify your outside, identify your inside, and then take turns with each derivative. Any questions with one? Okay, try number two.
We do the rule, and we have like, this in number two, we have 4x minus 1/3. You want to say, like, expand that?
You could, but if we want to find anything past this point, we like factor form, so these things in parentheses, it's going to be the best for future problems. But if you wanted to expand it, it wouldn't be wrong. Okay, with the remaining time, I'd like for us to go back to the handout that I gave last Friday, the power rule practice problems with that fractional. Is anyone not here Friday? Okay, let me get that to you. Yeah. What else? We did 1 and 2. Let's go to 3 and 4 on the back. And we talked about the strategy for these problems is I'm going to say on the quiz, do not use quotient rule, do not use product rule. You're just relying on power rule. And the reason that you can do that is because the denominator only has a single term. We can just expand, separate into individual fractions, bring all the variables up, and get it ready for power. This is what our problems should look like right before we do our derivative process. So it takes this much effort to get all the way cleaned up before we can apply power rule. So we first have to expand out x squared plus 1, x squared plus 1. Make sure you write it out twice so that you don't distribute the exponent through. If you distribute the exponent through, you're going to miss out on that middle term 2x squared. So you want to FOIL out. Then distribute the 2x to the 1/3. Remember, if you're distributing your x through, and you see other x's, you have to add exponents. Right? 1/3 plus 4, sorry, 1/3 plus 4 is same thing as 1/3 plus 12 over 3, which is 13/3. 1/3 plus 2 is same thing as 1/3 plus 6 over 3, which is 7 over 3. And then you can also begin to split up into individual fractions. Again, we're still not ready for power rule, so we got to bring the denominator variables up. In order to do that, we have to subtract exponents. So 13/3 minus 3/2. I need another denominator. I need 6 as my denominator. So 26/6 minus 9/6. This is 14/6 minus 9/6. 2/6 minus 9/6. All right, now we can do power rule. All right, so now I can bring the exponent down and then subtract 1 from the exponent. That will be your f prime. Your next step will turn your f into f prime.
Yeah, how'd you get 13 over 3? The first one?
13 over 3 by adding these exponents. So 1/3 is 12 over 3 is 13 over 3.
Okay.
All right, let's try number 4 as well. This one, see if you can do on your own, going through all your steps. Okay, so I encourage you guys to review and study for your quiz tomorrow. The additional handout that you picked up, that's going to be the morning review I'm going to go over tomorrow. But I think it'd be good if you use that as your quiz review tonight to study with. If you feel good about that worksheet, you should feel good about tomorrow's quiz.
Set the morning review time at 7.
Yeah, you're right. 7:30 tomorrow morning. I'll send out a reminder this afternoon. And then if you want to join virtually, I'll also send you a Teams link where you can join virtually if you want to watch that, watch me go through what kind of.
We get to 18 over 3x. We don't have to do like, we can just change all the day. I changed the limit by like 92. I get to 18 times 9 over 2 and then subtract that. I could just write that as 6x, right?
Yes. We should manage this now.
Okay, yeah, it's fine. I just haven't got to the end.
Okay, appreciate it. Yeah, I do want to check that. Yeah, thank you. Thank you.
I have homework from Thursday,
Okay.
and then we'll do pages for.
41, 42.
Okay, so that everything.
That's everything. Thank you.
So for this module, how do you know, like, how to, like, I get here and then I don't know what to do.
You basically have the answer here. The best we can do is to resolve that negative exponent.
Okay.
So I gotta put it in the denominator, but I can't put it in this denominator. I can only put it in the denominator within this space. So I just have to do a little complex math there.
Okay, and then do I combine both the ten?
Yeah. So you can, the x is gonna be x squared, the one.
Okay, so it's like x squared and it's over this.
That's right.
Okay, thank you.
Have a great day, guys. Study for your quiz. See you tomorrow.
Read me the answer. Read me the answer.
We do a lot.
-2 over 3x squared plus the.
Go on. There's probably worksheet.
And you said there's not gonna be any of those problems we learned like last Thursday or Friday? Like a week ago?
Oh, right. No limit definition, no alternate
Like,
definition.
spent a lot of time.
No, don't study for that. Do the morning review.
And power rule and PVT.
Yeah, PBA.
PVT. Okay, cool. Thank you.
All right, see you. You okay?
Yeah.
Okay.
I should have. Wanted to show you homework.
Yeah, that's right. 40.
Only like the top.
Yeah. It's gonna be just like a review sheet. So I would do this. So power rule, fractional power rule, finding Einstein equation, on this page. And then one page would be the function. Do this and then if you have any questions, you can have them up there.
I see a lot better than this.
Oh, bio. Yeah. Oh, yeah. That's pretty no better. And I got better grade.
It just was more fair.
Yeah, it actually sounds cute.
Because I think I don't need this.
Hey,
Unlike that's.
all that stress for nothing. And a lot.
How much time in September?
Well, but. This is something.
I got what I needed out.
Yeah.
Everybody does a lot. Yeah, that's right.
I forgot to put it down. Okay. When you ready, what? Got it.
I think.
Yeah. Like,
I don't know, I say.
It's like.
He gave us the form. You have a question about sex?
I'm not feeling it.
Yeah, I'm just like, I said the hydrogen bonds allow. Then second like the more, but it won't.
Yeah.
Okay, so it's like. So it's been 2 months. It's like, remember, I remember it's at the water.
I think I did.
The surface sensitive.